CNT125. We're on our voice over IP module. We're to the section now on IP phones. So we talked about, how would I adapt or connect analog phones? As companies moved away from their analog phones, they started adopting IP phones, which if you look around in businesses and even stores you go to, you're going to see these a lot when you really start looking for them. So the IP phone now kind of incorporates that ATA. So the phone itself has the built-in converter, built-in codec to packetize your voice. So then when it leaves the phone, it's already packetized for the voice network. This does require an IP address. It does require that it's going to connect into a network switch, and many times this is going to communicate directly with an IP PBX, and it might be a dedicated, if it's a Cisco IP phone, it's going to be a Cisco IP PBX server kind of thing. So there might be a little bit of proprietary nature there depending on the equipment you're using. If I spin these around, and I'm picking on this IP phone, we have a bunch of these, and these are kind of like a workhorse in business. You'll see these a lot when you look for them. As I flip this around and look in the back, I see a couple ports back here. If I look closer, there are two network ports. A better quality business IP phone is going to have two network ports. One is designed to plug it directly into a switch, and the other one allows a PC to plug into the phone. That allows this kind of arrangement here. The phone plugs into the wall outlet, which is going to go to your switch port. And then the existing desktop that was there can plug into the phone. So I don't need to have a second data port on the wall or a second switch port being used. This allowed for less equipment costs, less switch ports, less cabling ports installed in a building. So this shows you kind of the idea of how it's getting connected, and on the back showing you the idea of this port is designed to go to the switch, this is designed to go to the PC. I'm pointing that out because this is the typical business hookup that you would see. This is the kind of hookup we're going to configure for our switches to support the phone and PC. And it's also important that if I get these ports backwards, the phones aren't going to work. If I plug things in the wrong port back here, it won't register, the workstations won't communicate, etc. So I do need to pay attention to when I'm plugging in. This port goes to your switch, this port a PC can plug into. So do pay attention. Oh, on the back as well, there is a power cord port. Sometimes these get used. We're going to use them in our lab room because we don't have power over Ethernet switches. Businesses would typically not use those because we want to make sure our phones are powered all the time, which we'll talk about power over Ethernet in just a minute. So I start having this kind of hookup. The phone gets plugged into the switch, and then workstations in the office get plugged into the phone. And as long as I configure the switch to understand that or recognize that, it plays beautifully. And we will do that switch configuration when we set up our IP phones. We'll tell the switch port that, hey, you got a phone out there and you have a PC out there, and it knows how to handle that traffic. So IP phones have all kinds of features and things it can do. A lot of things it can do. Voicemail access, conference calling, call on hold, music on hold, speed dialing, you name it. Speakerphone, handset phone. And the big one is we can actually have the phone number tied to the MAC address, which is what we're going to do. We can tie a phone number to the MAC address, so wherever that phone plugs in, it retains that phone number, which is kind of cool. In the old analog phone days, as somebody moved around, you would literally need to pull wires out and punch them in so they retain their same phone number. This is so much easier. I can literally tie a person and a phone number to a MAC address, and wherever that MAC address shows up, there's Bill Smith, or here's Sally Smith, etc. I can keep that consistency. Big feature. With our analog phones, we get current from the local loop, from the phone company or the phone switch, if you will. With IP phones, we need electric current. It's not coming from the CO, if you will. So I need to either plug the phone into power, which we'll do in the lab room, or it gets the power from the switch, power over Ethernet switch. In businesses, that's typically how it's done. The power for the phone comes from a power over Ethernet switch. So the method we'll actually use a power brick and plug in the phone. And again, that works for us because we don't have power Ethernet switches. But in a business, you're typically not going to do that. The reason being, people are going to forget to plug their phone in, forget to plug the power in. They'll move their office around and forget to plug the power in. So all of a sudden the phone won't be on and they'll be like, hey, my phone's broke. It's like, no, you forgot to plug it in. Second reason is if we give the phone power from the switches are typically going to be backed up with battery backup, and then generator. So when you have a power outage, the switch is still powered from phone, or the phone is still powered from the switch, which is backed up by battery. So if you have a power outage in the building, the switches are still powered, and therefore the phones are still powered. So in an emergency like a power outage, the phones are still functioning. That is typically what businesses are going to do. So with that, we need to be thinking power over Ethernet. And there is actually standards for this. There's standards way back in the early 2000s on how to power phones. And over the years, there have been improvements and updates to that, giving you a little bit more power, a little bit more power, a little bit more power. And that is handy for, as the screens got larger, the screens got color, as we got video, these phones each consume a little bit more power. So we need to think about my switch is going to power these kinds of things. Phones, IP cameras, here's IP cameras, here's security cameras, wireless access points, etc. My switch can power all of those things, and that allows those to be installed where they're needed, not where power happens to be nearby. So I need to think about on my switch, what is it capable of? And as I look at all these switches, these are all capable of power over Ethernet. I literally need to look at the model number and the specifications of that switch to know what it's capable of. Here are 3 24-port switches, and there are 3 different model numbers. One does not do power over Ethernet. One is able to do, like roughly 200 watts. The other one's roughly able to do almost 400 watts of power. And obviously, as you buy these, each one's going to get more expensive in its capability. But I would need to know, what am I plugging in and what are my power needs? So I then look at my devices, what am I plugging in? And I can literally look up the specs on how much wattage each one of those uses. So I'll pick on 7940 here, this ballpark. Roughly 5 watts of phone. Oh, okay. So if I plug 10 in, I'm using 50 watts. If I plug 20 in, I'm using 100 watts. Oh, okay. So if I go back to my switches now, I plug in 20 phones, I'm using 100 watts. I'm still well within my range. That might be okay. But I do need to think big picture of what else is getting plugged in, because once I get over that number, the switch typically goes, I'm out. I can't provide you anymore. It's not going to do it. So I do need to think about what's going in, what it's using, and plan ahead for. That's why some people will typically buy a bigger one and just have it. But in smaller businesses, I might go with just the basics because I don't need much. Okay, so there is options out there. That's why you look at your model number specifications on your switches to know what is it capable of. The IEEE standard says the switch needs to determine whether a node is power over Ethernet capable. So it usually sends like a probing data packet. And then if it is, it's like, okay, well, here comes the power. And it literally provides power over the data wires. Now, it sounds weird, but the standard works out, the power over Ethernet standard works out that as I'm sending power DC, that's kind of like a constant level. My data moving by can my switches can interpret that, okay, this is a constant power signal. I'm going to pay attention to the data over here, the ones and zeros coming through, and it'll be able to keep those separate. Believe it or not, it's kind of cool. If I don't have a power over Ethernet switch, I can use what's called a power injector. And they make them in various forms. We used one of these in our church for quite a while to power an access point we put in above the ceiling. So I can use, if the switch does it, awesome. I can literally just plug the device right in. The switch is going to power it. If not, I can use these little injectors. So here's the switch, and here's the data. I literally have a second power cord go into this injector. It runs power across the data line along with the data. That combines the two. The splitter then pulls the power back out, and I literally can plug in the power cord from that camera or access point or whatever into that, and it'll power that device. This is exactly the setup we used in our church for quite a few years to get wireless access above the ceiling in like the children's area of the church. There was no power up there, so we just used an injector to get it up there. They had wireless in the children's area for quite a while because of that. And then here's another example showing you that here's the data going, here's the injector going out to the device. With IPPBXs, we also need to think about soft phones. Soft phones are an application I can install on desktop, laptop, and even smartphones that will act like a phone connected to the network. I pulled up Cisco Jabra here. That's what the college uses. I literally have this installed on my laptop. I even have it installed on my smartphone. So I can connect into the IPPBX as Doug Brown. I need to put my credentials in, and it goes, oh, okay, well, here are your phone messages, and then here also is a keypad. If you want to make calls, you can literally dial calls and literally make and receive phone calls through this application. During the pandemic, this became a lot more prevalent. People that may have never done this before started doing this, so they had access to what was on their desk before. A lot of places since then, I don't want to say have gotten rid of IP phones, but have really scaled down the hard IP phones on people's desks and just have this installed on their desktop, laptop, wherever. That way people can work in multiple locations. In Hack, traditionally I had an IP phone on my desk for years. With the pandemic, I don't. I literally have a soft phone installed on my various devices I use. So I can get to my phone messages pretty much anywhere now. Here is, we used to use in our lab room the X-Lite soft phone. Bria has bought it over, so it's the Bria X-Lite soft phone. And this can be installed on, again, a phone or laptop, desktop kind of thing to access an IPPBX. And again, you need credentials on the IPPBX. Doug Brown, here's his password. And then when this connects up, you need to plug in Doug Brown, here's his password. And it authenticates the user. And then it's like, hey, this is a phone in the network. It's registered. It can make and receive phone calls. So with my soft phones, I have a lot of functionality, a lot of features, graphic user interface. I can connect again on my desktop, my laptop, or even my smartphone. I can send and receive calls. Lots of flexibility. Lots of flexibility. All right, we'll come back in the last podcast and talk protocols.